Greetings. Welcome to our 39th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
And hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we are going to focus on our March 3rd, 2022 webinar titled Failure of a Geomembrane Line Reservoir Embankment, Field Observations and Numerical Investigations. I'd like to quickly reintroduce our presenter, Dr. Ria Bhaumik. She is an assistant professor in the Department of Civil Engineering at the Indian Institute of Technology, Jammu, with expertise in geotechnical and geoenvironmental engineering. Ria has extensive experience working on slope stability of landfill components and natural and reinforced earth structures. She has authored multiple peer-reviewed articles on slope stability and served as the principal investigator for funded projects on landslides and slope stability. So Ria, thank you for joining us again and answering questions from our live webinar and the survey after your webinar.
Thank you, Professor Stark. Thanks, Jen. Thanks for the introduction, and I thank both of you for giving me this platform.
Great. So let's start with the questions from the live presentation that we did not have time to answer. So there are about 11 of these questions. So here we go. How was the geomembrane installed around a drain pipe? Was a pipe used to connect the geomembrane to the pipe? And if so, how was it done?
Right. So if you recall and if you see the presentation, you will see that the geomembrane was not installed around the pipe drain. The geomembrane was present on the RWR1 side, on its upstream slope, and on the base of the reservoir. Below the base of the reservoir, at a certain distance, at a certain depth, the pipe drains were laid. So the geomembrane was not installed around the pipe drain. So I think that answers the question.
Okay. Are there any regulatory requirements or guidelines for these types of facilities or structures in India?
Right. So first of all, when we are not looking into exactly the lining requirements, so we mostly follow the Indian standard that is developed by the Bureau of Indian Standards regarding criteria for design of small embankment dams. That is IS 12169, and for the drainage system of such kind of dams, we look into IS 9429 1999. Now, the use of this geomembrane in such kind of water retention structures is relatively new. Like, it is more being in practice since last 1 decade. So we are rightly, but presently, referring to the ICOLD documents only. So the ICOLD 2010 document on geomembrane sealing system for dams, that is regarding the design principles on return of experience, that is presently being referred to regarding the geomembrane sealing system for the dams. So these are certain guidelines which are normally followed while designing.
Okay. Next question is, what is the main purpose of the main drain under the embankment? How does the water flow in and out of the reservoir?
Right. So again, if you can refer to the presentation, there I think in the introductory part I discussed that why exactly the main drain was below the embankment, and that is because the original proposed design was that the embankment needed to serve the role of a partition embankment. So that means it would originally have, as per the design, it would have to support water on both the sides, that is RWR1 side and RWR2 side. So in that case, you cannot exactly provide a drainage on the downstream side, because as such there is no downstream side when you have water on both sides. So that is why the main drain was below the embankment. And coming to the second question, that is how does the water flow in and out of the reservoir? So there was actually a properly designed inlet and outlet system which were connected to the sumps and then further to the pump houses. So that was the that was how the water was coming in and out into the reservoir.
Okay. Next question is, what caused the geomembrane holes or punctures that allowed the leakage underneath the geomembrane?
So, finding the causal factors is a little difficult. It could be anything ranging from, transportation stresses or, constructional stresses while, this geomembrane was getting, placed on the site. Or maybe it could happen also when the soil was getting compacted. So if presence of any angular material, although the soil that was compacted was originally silty sand, but presence of gravel, some particles of gravel could not be rolled out. So this kind of constructional stresses can also lead to, like it is the geomembrane is vulnerable to such kind of, construction stresses. Also, if you recall, if you refer to the presentation, you will see that on the upstream side of the slope, on the RWR1 side, uh, the geomembrane was overlain with a layer of cement mortar and then tiles. So both of these are not exactly, very compatible with geomembrane for lining system, because they, again, geomembrane further becomes more vulnerable to this kind of, pointy, like pointed tiles or the cement mortar. So there can be lot of causes which may result in geomembranes occurring these holes and punctures, and that is why it is recommended that a protective layer, either it can be a protective layer of soil, a protective layer of geotextiles. That is why these kind of protective layers are recommended whenever you are using geomembrane in your structure.
Okay, thanks, Ria. The next question is, what are the compaction requirements for the dam?
Right. So, it is said that we find out this compaction requirements based upon laboratory data, right? The laboratory compaction test. So, in the field, it is said that you achieve a good quality or a very strict quality control if you acquire it at around 98% of this laboratory values, like the moisture content values and the required density values. So, that is what was the recommendation. And these operators, because we were not exactly associated with the project during the construction of the project, we came in after the failure happened. So during that time, the tunnel, not sorry, during that time, the thermal power plant operators, they conveyed that that's what was followed, the 98% of proctored density and optimum moisture content of, I believe, somewhere around 12%. So yes, those were the requirements actually.
Okay, next question is, what are the factors that should be considered for determining the thickness of the filter that should have been included to reduce the potential for the failure?
Right. So every standard actually tells you about, a minimum thickness that has to be mentioned. And it is said as a minimum thickness because that satisfies the constructional constraint. So, when you are constructing this internal filters or the soil filters on slopes, so recommending a very thin filter is not always possible at the site. So that is why a minimum thickness as per the construction requirement is always mentioned. But the design requirement is the thickness of the filter should be sufficient to handle the quantity of seepage that is going to come. So that means the design of the filter, or for the design of the filter, you need to know what kind of seepage you will be, you can anticipate. And based upon that, you need to decide upon your thickness of this filters.
Okay, next question is, could a geomembrane have been used in the main drain system to reduce leakage? And I think they're asking, could a geomembrane have been placed underneath the piping and the main collection drain so leakage couldn't exit?
Okay, so when Professor Stark, can you repeat the question again? I think I need to get the question more. Yeah.
Okay, could a geomembrane have been used in the main drain system to reduce leakage? And I think they're asking is, could a geomembrane have been placed first and then the drain and pipe system placed over the geomembrane, so if the drains leaked, it would not have entered the ground?
Right. So if you recall, like this question is a little confusing to me. So if you recall the presentation, if you recall the schematics, the design, so you have the geomembrane liner, and below that the pipe drain, and the pipe drain connects to the main drain. So now if the suggestion is that can you place another layer of geomembrane just below the pipe drain and the main drain, I believe it would not exactly arrest the failure, because the flow channel was leakage of the geomembrane liner at the base of the reservoir. The water started leaking from that. It got a flow pathway from the pipe drain that served as a conduit, right, as a flow channel, and that got connected to the main drain. Now, since the main drain was clogged in the longitudinal direction, and the longitudinal direction was somewhat around 800 meters, so it got clogged. So the water could not find a passage to drain out from the area, and the least resistant path for that was to go through the other side, that is to the RWR side of the embankment. So I don't think, putting another layer of geomembrane below the main drain or the pipe drain would have solved this issue.
Okay. Next question is there a conduit included in the main drain? If so, what grade was the main drain installed at, maybe in relation to the reservoir? In other words, how far below the reservoir bottom was the main drain?
Right. So there was no RCC conduit that was part of the main drain. The entire main drain was made of gravels, and then layers of internal filter, and that was and that's was in touch with the local subgrade soil. Now, if you ask me what was the grade of the main drain, so the grade was actually around 1:400, 411. So if you see at the at the lower bottom side where the leakage occurred, the main drain was around 0.7 meters below the toe of the embankment. So if you calculate the depth of this main drain at the other side, at the outlet side of the entire picture, I think you can relate it when you look at the design. So there, I think the depth of this main drain was around or greater than 2 meters from the toe of the partition embankment. So that was the difference. That was the depth between the toe of the embankment and the main drain.
And Ria, you said 2 meters?
Yes, yes.
Okay, or 6 feet. Great, thank you. Next question. During the initial remedial actions, where were the pipes grouted? Why was the main drain not checked or corrected because it was not functioning?
That is actually a very good question. Now, the issue was, as I was telling, the entire length of the main drain was nearly 812 meters, like nearly some 1 kilometer. And there was no exactly RCC conduit. So, we cannot exactly flush out whatever was clogging. It was a completely gravel drain. So locating where exactly this gravel drain was, clogged in nearly a 1 kilometer section was difficult. So that is why the initial recommendation was close all of the flow channels by, closing the pipe drains, grouting the pipe drains, and then resealing the geomembrane. But as I discussed during the presentation, that was not followed. Only the pipe drains near the failure location, those were only grouted, and rest of the pipe drains were left out. So yes, this is definitely a good suggestion, but it seemed a little not feasible when we were working on it.
Okay. While protecting the outer slope with rock and soil, was internal friction between the layers considered? And I think they're asking, like, for example, the interface friction between the geomembrane and the overlying materials, as well as the rock and soil.
Right. So see, one part on the RWR one side, the layers that were used for the lining system was the geomembrane, and then above it was the cement mortar and the tilings. Now, the internal friction of the geomembrane and the local soil that we found out was somewhere nearly 22 degrees, and I think the slope was somewhere at around 25 degrees. So yes, there was definitely an issue of internal friction at the RWR1 side. But if you recall, the geomembrane is actually anchored at the top of the slope. So unless and until you are keeping it free, the probability of slippage is a little less. Now coming to the other side, that is on the RWR2 side, where we have layers of internal filters and we have that rock riprap. So there actually the internal friction of these materials, the friction angle, so those were greater than 35 degrees, and the slope of that side was 1:2.5, so that is nearly some 22 degrees. So on a slope of 22 degrees, material having frictional angle 35 degrees, it won't be a problem. Like the interface friction angle won't be a problem. So yes, on the RWR2 side, we did not have a issue. On RWR1 side, yes, we did look into when we were working on it, and I think we have addressed this in the paper also that is shared in the FGI library. So we looked into this issue while we were working out the solution.
Okay. Last question from the webinar is, why are unreinforced geomembranes like the HDPE geomembrane that was used in the project are vulnerable to cement mortar damage, and why then were they used on the slopes?
Right. So, in this is a very good question and a very rightly pointed out question. Is that in such kind of water retention structures, normally HDP geomembranes are not recommended. So reinforced geomembranes are definitely a better choice in this kind of structures. But yes, this is where educating the designers, educating the contractors comes into picture, because they believe that using the HDP geomembrane is same as using it in landfill and using it in exposed structures such as this that we have discussed. So so what I can say about this is lack of proper information, lack of proper knowledge about geosynthetics may be a result of this kind of structural failure.
Okay, Rita, now I'd like to turn to the questions submitted after your webinar presentation. And these questions were submitted via the survey that was emailed to all of the attendees. And we have about 10 questions here as well. The first question is, in case C of your seepage analysis, leakage was assumed through the geomembrane along the side slope and reservoir base. What infiltration did you assign to your seepage model on the upstream face that resulted in a factor of safety for the upstream slope of 1.1?
Right. So in case of C, yes, because we assumed a completely leaking liner along the upstream slope and also on the base of the reservoir. So instead of omitting a section of that low permeable material, which we were modeling in the other cases, what we have done, we have completely omitted this low permeable material. So that means, the complete face, the sloping face, the upstream face of the embankment and the base of the reservoir, the silty sand material, that was completely, in connection, that was completely exposed to the water or the reservoir head. So in case C, to model a completely leaking liner, we did not model that low permeable barrier material in this case. But yes, I think as I recall in case C, we did not model the flow channel, the flow pathway. So because we have observed in absence of a flow pathway, but even when the liners were not present, in that case, the factor of safety, it was not as per the design factor of safety of 1.5, but it dropped to 1.1, but it was still, stable because it was greater than 1. So that is how we modeled the case C.
Okay, great. Next question, why didn't they install seepage collars around the underdrain pipes?
Yes, that is actually a good suggestion, and that should have been the case. Like it could, arrest the seepage flow, the seepage channels. But if you recall, the design was made with the assumption that the geomembrane would never leak. And these pipe drains were present to arrest the fluctuations in the groundwater level. So, there were no question of arresting the seepage because the seepage was not considered in the original design. So maybe that is the reason they did not go in for putting out this seepage collars, which is normally a practice whenever you are putting a conduits in this kind of dam structures.
Right. Okay, next question. It was suggested that a cause of the failure may have been inadequate drain fill soil material or impervious material under the geomembrane between the base and the geomembrane. It seems the availability of suitable material was one of the reasons the facility used a geomembrane in the first place. So wouldn't have adding a non-woven cushion geotextile below the geomembrane been a more reasonable solution instead of more suitable soil under the geomembrane?
Right. So yes, during the presentation, I stressed upon the fact that the geomembrane should be supported with a secondary low permeable material, but that low permeable material cannot be a non-woven geotextile, because then that will act as a flow channel, that will act as, that will catch and that will act as a seepage channel itself. The non-woven geotextile can be provided above the geomembrane, which will act as a cushion layer, as a protective layer to the geomembrane. Moreover, if you again recall, the soil that we have used, not we, the soil that the designers have used to protect the geomembrane, that was actually locally available. That was the same soil that was, from the construction area that was compacted and put in above the geomembrane. So in here, exactly, like we did not, or the designers or the operators did not exactly transport any material from far away places. These were all local material which were used.
Okay, next question. Why was a 1 millimeter thick rather than a 1.5 millimeter thick HDPE geomembrane used?
Right. Again, that's a very good question. Because the permeability capability of a 1.5 mm geomembrane is definitely better than a 1 mm. But here again, the same, point comes that where when the design was taking place, the designers had the idea that maybe a 1 mm geomembrane functions in a similar manner as a 1.5 mm geomembrane. And this is where, more and more permeation of this education, more and more permeation of this knowledge is required, so that we are aware about which kind of geomembrane is best suited for this kind of structures and how they function differently based upon the polymeric material, based upon the thicknesses.
Right. Were all of the seams fusion welded with a thermal wedge welder and pressure tested?
Right. So we, when during the first phase of construction, they were welded, but as since we were not exactly connected with the project during that time, so we are not aware how exactly what testing were done or not. But when we suggested, when the remedial measures of grouting the pipes and then relaying the geomembrane, and that measure was taken, at that time we have recommended to go for this fusion welding and pressure testing the seams. And the operators did inform us that they have went for that, and I believe the pressure which they went in for checking was somewhere near 2 to 2.1 bar, as far as I recall. So yes, the pressure testing was done for the seams, geomembrane seams, when the remedial measure was there.
Great. Of course, groundwater uplift below a geomembrane is a common design issue. Could a recommendation been having no pipes below the geomembrane and just installing a gravel blanket first, and then the geomembrane over top of the gravel blanket, and the blanket would then dissipate the uplift pressures?
Right. So, if the question is, can we, kind of substitute the pipe drains with a gravel blanket, gravel drain, I think it can be done, provided it was again geotextile wrapped, so that it would not be clogged. I think that solution seems better, but yeah, I think, yeah, this could have, captured the failure in a better manner.
Okay, great. Next, are leak location surveys or electrical leak location surveys after the geomembrane is installed common in India, either at completion of the geomembrane or even long-term maintenance, say 1 to 5 years after the installation date?
Right. So it is still not common in our country at present, actually, but yes, slowly it is coming up actually. So yeah, I have seen in some of the projects the designer recommendation, and in fact, at the tender document they are mentioning to go for this leak location surveys right at the just after the installation of the geomembrane liner. I'm yet to see for a recommendation of a leak location survey after 1 or 5 years for maintenance. But yes, these are slowly coming up, but it's not a widely followed practice yet.
I like how you ended that, Ria, saying yet, because they've been really effective in the United States. So hopefully they'll be used
Yes,
more in
yes,
India.
yes, yes.
Okay, next question.
Yeah.
Would an exposed HDPE geomembrane have been a better solution for RWR1 and 2? It appears leaks in an exposed geomembrane would have been easier to locate and repair than your project, where the geomembrane was covered with a mortar, brick tiles and mortar.
Right, right. No, actually, an exposed HDP liner is never a good solution because it has been reported that this kind of liners are more vulnerable to, punctures and tears. So, covering them with protection layers is definitely always recommended. So I can understand why this question is coming up, to locate the leaks in a much better way. But no, for that is why we have leak location surveys, but exposing the geomembranes is never a good idea.
Okay, great. Would a reinforced geomembrane have been a better solution than an unreinforced HDPE geomembrane to line the water reservoir?
Yes, yes, definitely it would have been a far better solution actually. And that is why, again, herein, that education needs to be there. That was the difference between a reinforced geomembrane and a normal HDP geomembrane. And the usage, the application of this kind of geomembrane cannot be the same. The applications are not the same. So yes, the reinforced geomembrane would have been a much better choice in this case.
Great. Okay, Ria, last two questions. I've seen underdrains used beneath geomembranes in the past for high groundwater conditions, but I believe they were surrounded by gravel and encased in a geotextile, and that geotextile having a function of a filter, of course. Assuming the main drain and underdrain pipes used in this design, would the embankment failure have occurred?
Right. So, as per my understanding, if the main drain would have been, wrapped in a geotextile so that, the filter layers on the main drain clogging can be prevented, I think that would have definitely arrested the flow channels. So, yes, I cannot definitely say that it could completely prevent the failure, but yes, it can definitely delay the failure. It can, and if the main drain would have been functioning, then the water would have got a path, a flow channel to flow via the main drain instead of going to the RWR2 side. So yes, wrapping up the main drains and the under drains with the geotextile would have been a better solution here.
Okay, last question. Would a composite bottom liner system have performed better below RWR1 and 2? For example, from bottom to top, a GCL, a secondary geomembrane, a geocomposite drainage layer, and a primary geomembrane with a drainage layer on top of it draining to a sump and the water pumped back into the reservoir from atop of the secondary geomembrane. In other words, from the witness geocomposite drain between the primary and secondary geomembranes.
Right. So it definitely looks like a better solution, but I could not resist and compare it with the composite liner system that is normally used in case of hazardous waste landfills, where you go in for 2 layers of lining systems. I believe in the case of this kind of structures, maybe we do not need to be so much stringent. Just a layer of geomembrane, reinforced geomembrane, along with the secondary low permeable material, I think that can suffice the function. But yes, if some operators want to be very strict, they want to be extra safe, then definitely a composite liner system sounds good.
Okay. Well, Ria, that's all the questions. So thank you for joining us again and giving us first an excellent webinar and answering something like 20 questions from the webinar and the post-webinar survey. So if you have any additional questions or want additional information, please send your question to the FGI at fabricatedgeomembrane@gmail.com. Or Ria, can you give the listeners your email address?
Sure. So you may reach me at riya.bhowmik, BHOWMIK, @iitjammu.ac.in. So a simple Google search of Riya Bhowmik will lead you all to my institutional website, and you may reach me from there.
Great. So Ria, thank you again. And thank you for everybody that is attending. See you next time.
Thank you.
Bye.
Thank you, everybody. Thank you, Professor Stark. Thank you, Jen.
Thank you.